All right, so the Pythagorean Theorem, very famous theorem that a lot of people tend to remember far beyond their time working with math on this level on a regular basis. So the nice thing about it is even though the name is kind of weird and maybe a little intimidating, it's actually kind of cool. So let's just take a look at the formula first. You might recognize it. Maybe you haven't ever really used it before, but it should sound familiar. And if not, that's okay. We'll learn about it today. The formula is a squared plus b squared equals c squared. So maybe something you've heard of before. The interesting thing about the Pythagorean theorem is that it only works with right triangles. So a right triangle, remember, is a triangle that contains a right angle. A right angle is a 90-degree angle. It doesn't work on other triangles unless you break them into right triangles. So break them into pieces and create right triangles within a different triangle, and you can still use the Pythagorean theorem. You just have to use it in pieces. Okay, so we've recognized now that it only works with right triangles, and we need to talk about these letters, A, B, and C. A, B, and C represent side lengths in your right triangle, and we use that formula, a squared plus b squared equals c squared, to help us find side lengths in our right triangles. So A and B are kind of flexible. It doesn't matter which side you call A and which side you call B after you recognize which side must be C. C is the important one, and C is the one that has to be the longest side. You always find the longest side across from your right angle. So if you draw a little arrow from the box that represents the 90-degree angle in the corner, that arrow points to C every time. So that's pretty nice. So if you're wondering which side is C, find your right angle, draw a little arrow from that corner of the box, and it will point to C every time. And like I said, A and B are flexible. You can call this side A, you can call this side A, it doesn't matter. But whichever side you call A, then that forces the other side to be B. All right, so let's talk about C. C must be the longest side. It's always found across from the right angle. And if you think about that for a moment, it does make sense that it has to be across from the right angle. If you go back to how many degrees are in any triangle, hopefully you remember that's 180. If we have 180 in the corners here, we already have used 90 in this corner. 180 minus 90 leaves us with 90 degrees that are going to be split between these two corners. So neither one of these corners could also be 90 degrees because then we'd have nothing left for that third corner. So this has to be the largest angle, and across from the largest angle, you will have your longest side. So because C is so important, it actually has kind of a fancy name, and that fancy name is hypotenuse. So if you are asked to find the hypotenuse of a right triangle, they're just asking you to find the length of the longest side, which is always found across from the right angle. All right, so let's talk about what the formula means. A squared plus b squared equals c squared. You could also say a to the power of 2 plus b to the power of 2 equals c to the power of 2. There is a reason, though, why we call the power of 2 a square. And that is because the area of a square can be found by multiplying the side lengths. So this side length times this side length would be side length squared. In this case, we have our right triangle in the middle. We have C on this side length, which makes this square that I built off of that side C times C in area. C times C is C to the second power, or C squared. So the area of this square is one side, C times the other side, c times c, gives us c squared. The same thing happens with a and b. We have a here or a here, it doesn't matter. If we call this side a, the area of this square that I built off of this side would be a squared. And finally, this side length, if I call it b, the area of this square would be b squared. So the Pythagorean theorem says that if I take the area of this square and I add it to the area of this square, it will equal the area of this square every time. There are many ways to prove this. There's one that I like in particular for you as 8th graders because you just need the general idea that this square plus this square is going to equal this square every time. Or if you take this square and split it up, all of this would fit into these two. So there is a proof that is shown in a video that I have put into your folder on Schoology. It's about a 40-second video, and it involves water and a wheel that gets turned and the water moves between the squares. And it just kind of shows you how if this square was full of water and they turn the wheel so that it fills these two, it would be empty and these two would be full. And when these two are full and they turn the wheel, the water will fall into this one, these will be empty and this will be full. So it just shows you that a squared plus b squared equals c squared, just like the formula says. So check that out. It's pretty interesting. All right, so let's look at an example so that we can see how the Pythagorean theorem can be used. So remember, the Pythagorean theorem is about the side lengths in right triangles. So this example says find the missing side length, and we have a right triangle. We've been given two sides. We definitely have one that's missing. We need to realize which side is A, which side is B, and which side is C. Remember, C is the one that's important. C is the one that is always found across from the right angle. So there's our arrow pointing at C, and C is the one that's missing. It's the one that doesn't have a value. Not yet, anyway. We're going to find it. All right, so let's use the formula. A squared plus b squared equals c squared. C is our unknown. That's the one we're going to solve for. So we need to leave this just a c to the second power, or c squared. A and b, like I mentioned, it doesn't matter which one goes into which variable. So let's say that a is 6. And since I need to raise it to the second power, I'm going to write that down. And b, we will say, is the 8. If you switch it around, it doesn't matter. You're going to get the same result either way. All right, so we need to simplify, and we need to follow the order of operations. So we definitely take care of the exponents before we add. 6 to the second power, that's 6 times 6, not 12. Be careful. Sometimes you kind of get to the point where you're like, oh, this is pretty easy, and then you make those kind of mistakes. So just be careful. 8 to the second power is not 16, it's 64. Again, just pay attention. We can go and add those, and we get 100. Now, what this is saying is that 100 is the area of the square that we could build off of this side right here. But we don't want the area of the square. We want to know how long is just one side of that square. So we need to find the square root. What number times itself gives us 100? And that symbol looks like this. So we want to know what is the square root of 100, and hopefully that's one that's pretty easy for you. 10 times 10 gives us 100. So the square root of 100 is 10. Remember, what you do to one side of your equation, you must do to the other side. And we have a square root over something that is being squared. Squares and square roots are opposite operations. They cancel each other out. Kind of like if you pick a number and add 5 and then subtract 5. Adding and subtracting are opposite operations. You add 5, you subtract 5, the number is just back to its normal self. In this case, we have a number being squared, or a variable being squared, and then we're taking the square root. They just cancel each other out, and we end up with just c. So the length of this side is 10. And you want to kind of check to make sure that that makes sense. C has to be the longest side. In this triangle, 10 is definitely going to give us the longest side out of 6, 8, and 10. So we're good. We got it right. All right, let's do one more. We've got a right triangle again. We've got a missing side again. Use the right triangle to help you identify which side is C. And C is our missing side again. So here's our formula. A squared plus B squared equals C squared. C is going to stay just C because we don't know what it is. That's what we're looking for. A and B, flexible, doesn't matter. So we could say that 7 is A and that 4 is B. And when you put them into the formula, you have to remember that we're raising them to the power of 2. Same with C. We put C in, we're raising it to the power of 2. All right, so 7 squared, 49. 4 squared, 16. 49 plus 16 gives us 65. Now, what makes this one different than our last example was that when we added a squared plus b squared, we got a nice number that happens to be a perfect square. 100 was a perfect square. 65 is not a perfect square. So we are not going to get a nice integer as our answer. We're going to get either a decimal value, or we could leave it as a square root. So it depends on what the directions say, and I intentionally did not include directions as far as that goes, just so I could show you both possibilities. So the most accurate possibility, because you're not rounding at all, is going to be just leaving it as a square root. So you would put the square root symbol over each side because we don't want to know the area of the square off of this side. We want to know how long is that side length. So the square and the square root cancel out, and the square root of 65 could be how you leave it. They might say leave it in square root form. They might also call this radical form. Radical is the fancy name for the square root symbol. So either one, it might say square root form or radical form. But they might also ask you to round to the nearest tenth. So you could use a calculator to find the square root of 65. You should have a pretty good idea of what it is because we have talked about how you can estimate square roots. Just kind of off to the side here, 64 is the closest perfect square to 65. And then the one after it would be 81. The square root of 64 is 8. Square root of 81 is 9. So the square root of 65 is going to be just a little bit more than 8 because it's much closer to 64 than it is to 81. So maybe an estimate would be 8.1, 8.2. And that actually is what it is when you calculate it on your calculator. When you type it in and you round it to the nearest tenth, you would get 8.1. Double check that you've got a number that makes sense for this triangle. Is 8.1 the longest side like it should be? Yes. So you know that your answer at least is reasonable. Hopefully accurate as well.